Hi, my name is Mary Kerr, and today I'm going to be telling you about drying with anhydrous agents. So right off the bat, what it's used for is you add it to a solution to remove trace amounts of water from an organic solvent. And then it's also used in just a lot of practical applications to keep things from becoming damp, like those little silica packets. A lot of times there are those little white packets that come when you order things, and those are also used to just remove moisture from the air. And as it says right here on the slide, many reactions in chemistry are sensitive to water, and the reagents will react with water in the air without anhydrous agents added to the solution. So in order to actually get the products that you want, and not to have these side products that the reactants have reacted with the water and the air, it's important to have those anhydrous agents present. So how does it work? Many organic solvents do not dissolve in water because they're nonpolar. However, the more polar an organic compound, the more likely it is to dissolve in water. But still, even with being nonpolar, some organic compounds are able to dissolve significant amounts of water due to their the polarity present within the bond. And those are typically the reactants that are important to have coupled with an anhydrous drying agent. So there are a lot of different drying agents used, but these are the four most common: calcium chloride, sodium sulfate, calcium sulfate, and magnesium sulfate. And kind of the process of it and what you see on the visual side, there's a photo coming later, but the water will cause the drying agent to clump into particles larger than the original particle size and possibly stick to the glass. And that is a sign that the agent is wet. And so I will show you later how you know that the anhydrous agent has actually worked. So some tips: avoid adding an excess amount of drying agent because you don't want to absorb all of the polar compounds and then for that reactant to be out of the solution. So you want to avoid a loss of product. And then make sure you don't leave the container of the agent exposed to the environment or the air in the lab, or else it will absorb all the water. Okay, so in order to do it, you're going to separate the organic layer from the aqueous layer using a pipette, or like we did last week in lab, you could drain the aqueous layer out and then you would just be left with that organic layer in the separatory funnel, and then you could probably just filter that into an Erlenmeyer flask. You're going to add a small portion of drying agent to the flask. Swirl the flask and continue swirling until small particles the size of the original drying agent appear in the flask. So earlier it said that the drying agents may be larger and appear wet looking, and so you're not looking for that. You're looking for them to settle out of the solution with a very similar look as to how they were when you put them in. If you're swirling for a while and small particles still aren't seen and the mixture isn't translucent, add more of the drying agent. It's always better to add a little bit in the beginning and then slowly add more, so you don't add too much. And then just remove the drying solution through gravity filtration by decanting, or also, by decanting through gravity filtration or vacuum filtration. And then you're just going to rinse the drying agent with fresh non-dried solvent and combine rinsings with the dried solution. And even though, from my research, even though you're rinsing it with a non-dried solvent that hasn't undergone the reaction with the drying agent, it still is all right, and it doesn't make significant effects to the overall reaction. And then you can remove the solvent by evaporation on a hot plate. So on the right-hand side is a solution that has the correct amount of drying agent, and you can see how it's just kind of like a fine dust that has settled out of the solution. Whereas on the left, they've added too much of the solution, the drying agent, and it's the particles in the flask on the left are considered to be wet particles, and that is not what you're looking for. So you're hoping to finish with something that looks like the photo in the right, and then it's easy to separate the drying agent out of the solution. These are some of my sources that I used to find this. Thank you for listening.